Hey there, I'm Nate Smith. This is hour two of what I'm hoping to be about 100 hours of me practicing my refactoring skills. Uh, you can see all the other videos up on my YouTube channel. Um, Today, we're going to continue, or we're going to reset what we did yesterday and try again. Yesterday, what we did was the Gilded Rose Kata. It was our first practice session, or my first practice session, and it didn't go as well as I had hoped, which is good. Made a lot of mistakes, and in reviewing them, um, there were quite a few. The biggest ones were um, there was some Git configuration regarding line endings that caused some distraction when making commits. I've since fixed that, I hope. And then the other thing was just getting my project set up in my development environment was kind of a drag. There were some gem installation issues, and I didn't know how to use a particular tool called approvals right off the bat. Now that I know, and we got a little practice in yesterday, I think that won't be as much of an issue. The other thing is I can copy a lot of the project configuration that I did yesterday into this new kata, and so hopefully I'll get further along than I did. There are a few other things that came up that I was hoping to be able to address before this practice session. One of them was getting branch coverage markers in IntelliJ. It turns out that IntelliJ's code coverage module or plugin doesn't actually support branch coverage indicators. And so that's kind of a drag, but it is what it is. We'll have to do without it, at least in the Ruby side. When I go on to do other programming languages, maybe branch coverage tooling will be there. The other thing was I wasn't familiar with the refactoring that I was actually doing, and hopefully more of a larger proportion of the mistakes I make are in the actual activity of refactoring, and not in like getting projects set up correctly and stuff like that. The last thing, and maybe the biggest thing, is that my typing is terrible, and especially the accuracy of that typing. So I'm gonna give some thought into whether or not I should do like a type racer training every day just to get my accuracy up. But that was something that was definitely an issue. Related, I had ligatures turned on in IntelliJ, and while ligatures can make reading code more pleasant, it actually makes editing harder, because what looks like what looks like one character might actually be two, and you might want to change in my case, I wanted to change a not equals into an equals, and that was made harder by the ligatures. All right, so that covers the mistakes that I made, the basic mistakes I made that I want to improve. Let's get into it. I'm going to set a timer for an hour. It's going to be hour two. I've got the basics set up in my practice Git repository. There'll be a link in the description of this video. These I've just copied straight out of Emily Bach's repository of all the different Gilded Rose kind of templates. We aren't going to be using Gilded Rose tests or the text test fixture. Say that 3 times fast. But we are going to be using these two files. We'll probably want a gem file. Let's just copy yesterday's gem file. cheating, but I don't want to spend as much time on. Actually, the other thing is we're gonna want yesterday's shell.nix. This is gonna give us. I'm copying it out of this directory. We want yesterday's shell.nix. This is going to give us the libxml stuff so that we don't have to fool around with that. And the last thing that I want out of this is the mrc. And so that's a dir-env configuration. Finally, there are a couple, so we want to configure the Nokogiri stuff, get that out of the way. And then there is one more, so we just want to tell bundler to install into this local project directory. And this will get us pretty well set up right off the bat. I'm just going to start the first part of this in terminal, get everything working in the shell, and then I'll import it into IntelliJ, where we'll be doing most of the work. So now if I run rspec, didn't find any examples. Let's make spec and lib files. Let's move Gilded rows spec into spec and move Gilded rows.rb into lib. Let's see if we can get that test failing. Okay, so we get that's because there's like a hard-coded path in here. That really should be in the load path if this was a production project, but it's not, so we'll just require relative. So we get a test failure, which is what we wanted. The other thing we want to make sure is that this approvals bin is there. Okay, it's time to import this into IntelliJ. I was trying to get that line endings thing fixed earlier. So we're going to create a new project. I've already done a little bit to get this going. We're on our second practice session and that directory already exists. So let's see if we can avoid all of the pain that came with trying to do this yesterday. Looks like everything is installed correctly. Let's bust open this, run it with coverage, and see if it fails. Yeah, so it fails. I don't want this in my face all the time. I actually don't care about project level coverage. I'm only using test coverage for these gutter markers, and that is going to guide some of the refactorings that we do. So let's commit this actually. I'll just call this setup. No errors and 3 warnings found. Let's review. I mean, the tools, rake, and approvals are not available. Okay, that's really interesting because I think that we have. if I look at the project, external libraries, no, we don't have rake, we don't have approvals. I think our SDK is messed up somehow. And I just want to make sure that we get this right. So that's the gems directory, and that's the right, the language level is wrong. Um, I wonder if maybe I set the bundle path to be the wrong thing. No, that looks correct. And which approvals points to the right thing. So approvals is right there. Okay. Okay. For some reason it's not picking things up. I wonder if there is a way to have this pick things up correctly. Let's do another bundle instead. Still not picking things up for some reason. Is there like a, oh, looks like we're getting more out here. I don't know why removing RSpec. What if we remove everything? See, this is becoming more and more of an issue. The language level is the wrong language level. Let's try doing which Ruby here. Okay, so it's in the Nix store. And bin Ruby. So that's definitely a Ruby. This is our bin directory. Might be worth invalidating caches and restarting. I've never seen this actually be helpful, but it's possible. Um, this does make me wonder if Nix is really worth it for me. Um, like if I'm going to be doing a lot of these practice videos, and I am, it might be worth kind of getting on the right track with IntelliJ, the blessed path, right? Um, the reason I use Nix is because it has a number of really good properties compared to Homebrew. Um, I work across a broad set of projects, and so it's really okay. So invalidate caches actually did work. Fancy that. Now I think when we commit, we won't get those issues with the code analysis. All right, let's make sure that we can run that test again. I wonder how much time I've wasted on this. You know, not a totally crazy amount. Probably not worth ditching Nix quite yet. Nix basically makes it really easy to have completely isolated project-specific environments, and that's really important to me because often you need to use a bunch of version managers in order to isolate which version of a particular language runtime you're using. Like, I used to use ASDF or Cherubi. There's Node version manager for Node runtimes and JM for Java, and that was getting really clunky for me. And the other thing is, while those do a fairly decent job of isolating like language runtimes, what Nix lets me do is isolate dependencies as well. So if I need a particular version of ImageMagick, I can have a project-specific version of ImageMagick. The same for libxml. Like we saw in the last video, you need libxml for Nokogiri. Certain versions of Nokogiri compile against certain versions of libxml. So if I need those versions, I can pin them using a Nix environment. So that's why I use it. Unfortunately, like editors and in particular IntelliJ just aren't well integrated yet with that. But let's get this committed. It's going to perform code analysis. I imagine that we'll have fewer warnings or errors. Okay, so no errors and one warning. Let's just commit it. I'm not super worried about that. All right, let's get after this a bit. Just to start, let's use the explicit version of that. Let's separate the phases of this test. And let's get this test passing. All right, so we have a passing test. There, we're good. One of the other things I wanted to see or one of the problems I was having last time is selecting code in a particular block. So if I'm using Alt up, I think this actually, yeah, so that'll expand and shrink the selection. So that's a really useful thing to know, and that way I can avoid some of the more error-prone cutting and pasting that I'm going to be doing later on. All right, so we have approvals already. Um, we have it already installed, but one of the things that we do need is we do need to set up RSpec to see approvals. And the way to do that is to have a spec helper. Yeah, we do want it in source control. Pulls RSpec. You know, I've complained a lot about IntelliJ, but the autocomplete and stuff like that, I don't have available to me in Vim, which is my usual day-to-day editor for Ruby. And it is pretty nice. Okay. I don't need to see this anymore though. And actually, let's, oh, that doesn't work. Let's just put that in our spec helper. That way we only have to require one thing. We can put common setup in there. Okay, so we've set up approvals. It's interesting, like I don't, I think the code analysis thing is nice, but we might want, I'm gonna write down that little pause is probably too much for the feedback loop I'm looking for. I want seconds or less than a second ideally. I don't want any interruptions, and that disabling that code analysis for the next time is gonna be something I want to do. All right, so I'm just writing that down in my notes. Let's just leave this test. We fixed it. Let's say we want to be able to run these approval tests. The way to do that is to just run it inside this, or run a verify block inside of one of these RSpec test methods. Our approval files will be saved based on the name of this test. One of the things that these kinds of tests are called, there's approvals, but in the book Working Effectively with Legacy Code by Michael Feathers, he calls tests that kind of cover an untested method are called characterization tests. I don't know if this is exactly what he means by characterization tests, but I think it's useful to think of the approval tests as characterization tests. So we can just say it is characterized, I think, here. And that is a useful description of what we're trying to do. Okay, so this verification, I just want to turn off. No, I don't want to turn off auto test. So we're gonna get some approval errors here, which is fine. What I want to do to start though is hit at least. I want to start hitting the red with my approval tests, and as I hit the red, we'll commit the approval, or we'll approve whatever output there is. So we know that what we want is to see the two-string output of the items after we've called updated items. or update quality, because update quality we can see here and here. It's actually mutating the item object, and the item object has a 2s method, and so we're going to use this 2s method the as the kind of output that we're going to approve. And so what we're going to do is say items dot map to s is going to be the thing we approve on, which means like, well, what is items? Items is going to be our item names, combined with the sell-ins and the qualities that we're gonna put together here. Let's do sell-ins first, just to match the order of the constructor and qualities. Yeah, I don't mind that. And we're gonna say name, sell-in, and quality are the fields here, and we want to create an item for each of these. These are just going to be name, sell-in, and quality. Okay, so now we have the items. We're not going to only map them. We're going to do gilded rows.new with the items, just as we did up in the previous test there. Update quality. And we're still getting errors because we don't have names, we don't have qualities, and we don't have sell-ins. So let's just start with let's get aged brie in there. Sell-ins, we're going to start with just what we had with in the first test, which is 0, and qualities is also going to be 0. All right, so we can see, like, if we just back out here, that change, we'll see, like, okay, all of this is red, and then when we add back in the qualities, we can see that we're starting to hit some of these lines here, which is fantastic. We can now go into our approvals tool, and we can see that we can age brie, we can approve that. Let's just run it again. We should see the test pass because we've now approved. And let's commit. So test, we'll say aged brie. Commit. All right. So now it's time to go and try to hit each of the parts here that are red. Our best bet is to start covering what we see as valid inputs. So let's put backstage passes in. And what else do we got? We got sulfurous. And for qualities, we go greater than 0. Let's just make sure that we hit around each boundary here. And sell-ins, we've got this like around 11. So let's do 10, 11, 12. Quality we have around 50. So let's do 49, 50, 51. We have this 6 for selling. So let's make sure that we hit 5, 6, and 7. This is the thing about split keyboards, is that I'm used to the number row being kind of a continuous row, but it's split across my keyboard, and so especially around 5 and 6 where the keyboard split is, I get a little inaccurate. So we have 5, 6, and 7, 49, 50, 51 on quality, 10, 11, 12 on sell-in. Sell-in 0. So we have 0 itself, but we should probably cover -1, 0, and 1. Quality, okay. We have qualities greater than 0. And then we aren't hitting this line, and we aren't hitting this line. And so I wonder, okay, so what we should do is we should think this through. I think the last time I did this, I didn't think it through. So if the item name is not aged brie, right, we are covering that case, backstage passage, and the item name is not backstage passes, we are covering that with sulfurous. So we get into here. If the item quality is greater than 0, definitely covering that. If the item name is not sulfurous, okay, so it has to be not aged brie, not backstage passes, and not sulfurous in order to hit this line. We don't have an item that's none of those 3 names, so let's stick one in here. I don't love that it just stuck a line break in that string. Let's try to undo that. Oh. Even that it indents to 4 spaces is also strange. I'll take a note for that. Indent to 2 spaces. IntelliJ, thank you very much. All right. So we're all green here, we're all green here, we're all green here, we're all green. You've got the whole thing. Let's verify the approvals. So we got 215 test cases, and these cover basically every permutation of the item names and then the important sell-ins and qualities. And with this, like, we can start to refactor with a lot of confidence. So let's prove this. Bump back into IntelliJ. If we run this again, we should get green, and we can where we're gonna end up here is a spot where we can now I think it's possible that I wasn't committing anything before. Okay. What? Yeah, obviously. Was I not getting this? Okay. Anyway, all the pop-ups and stuff in IntelliJ drive me crazy. Okay, so we now have these tests. I think we can kill that split just because I want to focus on the production code. Now that we have this coverage and we're auto testing, we can start refactoring really, really aggressively, while being confident that that we're not breaking anything. Okay, so that was just some stylistic stuff. Um, let's commit it. This analysis thing. Okay. First thing, let's get this extracted. What do we want to update item? That's what we'll call it. That's what it's doing. All right. Now, one of the things that happened last time was I wasn't able to get okay, so what happened last time was I wanted to start pulling out and peeling out some of these conditionals, and I just didn't end up able to do it. And part of the reason was I didn't know what I was doing. Actually, that was the whole reason, is I had an understanding of what the refactoring looked like, but I didn't have an understanding of how it worked. And I think I have a better understanding of how it works this time. Basically, what you want to do is you want to take you want to take any of these conditions, right? And you want to make sure that when you want to lift them out, what you can do is you can just take the condition, put it in an if else, and then duplicate the inner code on either side of that else, and look at how code coverage changes. And so that's what we'll do here. We'll the first thing that we're going to do is make it easy to duplicate this logic on either side of the else. And the best way to do that is just another refactoring. So we're going to call this applesauce because this one doesn't matter. So we want to go up to the whole method and then down one. So now we know that we're selecting, I'm pressing Option up, I think, or Alt up. And so let's extract this method again. Call it applesauce. You can see that item is its only parameter. All right. So we're still covered. We're still passing. That's good. Let's commit. We're going to use the same commit message. Yeah, this code analysis. Let's see if we can get rid of it right now. Okay, boom. And I don't care what checkout to do. Okay. We're going to do if we can do if else. Item.name equals aged 3. And so that should still pass because that's a no op. Let's get really weird about committing. That's an empty if. What we can do here is duplicate this into both branches, and that is equivalent. So we can duplicate the statement into the if. And that is equivalent to the original code, which is the empty if with the statement following it. And then this is kind of where the magic happens. What we're going to do here is we're going to inline that method, and we can actually remove the method. I don't care about the method. Ooh. So this is the inline method refactoring is not supported when return statements interrupt the exclusion flow. So cancel out of this. Let's see where the explicit return is. Oh, so we don't have an explicit return. So I'm not quite sure what it means. Maybe it means that those methods rely on, okay, maybe if I put an explicit return in here, so maybe there's an implicit return. So it sees, okay, so Ruby's expression oriented. So this is implicitly returning. So applesauce, the value of applesauce will be returned from update item, and the value of applesauce will be returned from update item here. It's possible that IntelliJ is analyzing this method and seeing that the return value will be affected, and so it doesn't want to inline. I actually think, let's see what happens. So say I put an explicit return here. If I try to inline that now, I don't want to keep the method, right? I want to remove the method. Right, okay. So what happened there was, once I added the explicit return, IntelliJ was able to see IntelliJ was able to do the analysis and see that that the return worked in both cases. So that's really interesting. I'm gonna have to think a little bit more about that to understand it, but that's effectively how you do a really safe, almost automated, largely automated duplication into both branches of an if. I'm just gonna take a brief break. I'll be right back. All right, so I was gone for a little bit there. I think we had 19 minutes left. Okay, so we left off with the safe inlining of that applesauce method. The thing that we should probably do is inline is we're gonna commit that change. I just want to be basically I want to make safe changes the whole way through. So that was a completely safe change because the first of all, it was fully automated, but second of all, it was the equivalent code. So if you have the method on either side of the if and else, and then you inline it in both sides, that's provably safe. It's very mechanical, and it's the kind of mindless refactoring that I want to do in order to be able to approach any piece of code this way. So, and now we can get to the productive part. So we can see in this, when the item is equal to HBRE, none of this code here, so this if doesn't run at all, which means we can select it and delete it safely. And we're going to get green here, and we're going to be able to, I'm going to copy this message because it's going to be pretty useful. So we can see that this line runs, but this line doesn't, which means that is empty, which means that that is empty. And so we can say if we're going to be green, and delete red. Yeah, we're gonna do this a lot. So you can see that this if statement doesn't run. Let's save. Let's call delete red. Yeah. And so now we can see this is all of the code that runs when the item is equal to HBRE. So if we know it is HBRE and we know this is not HBRE, so we know this else statement always runs. And what we can do is just paste it there. We know that this statement always runs, so we can just paste it there. We know that this statement always runs, so we can just paste it there. So now we can see this is all the logic for HBRE, and we've actually extracted out mechanically. Like, I still don't know anything about quality or sell-in or what HBRE does, but this is the code that runs when the item is HBRE. And we're just going to call that delete red again. Now we're at the part where I got stuck the last time. We're not much further along than we were in the last practice session, but I'm convinced that I will get this the project setup stuff smoothed out enough that I can spend more of the time on the meaty part. Okay, so what we want to do here is we want to extract out the next conditional. It's probably good if that is backstage passes. I think our best bet here is to extract this method again. We're gonna call it applesauce. We'll get passing tests. So what we should end up with, let's copy this backstage passes string. so that was totally safe. We can now commit this as duplicate conditional. I don't know if that's what I would put in production code, but now when I inline this method, I should be able to go through the similar process. So we can see that this statement doesn't run, and so we can delete that. Commit it as delete red again. All this stuff runs. All this stuff runs. This if statement doesn't. So we can delete it. Let's save, commit. This doesn't run. So green, delete red. Okay, so we're good again. I'm going to delete this implicit nil. So we know that this always runs. We're doing this based on item names, so we know this always runs. Oh, and this can just paste there, and it's the same. We know that this always runs. Oh wait, what? I should commit. Now it feels like I'm actually practicing. You know that this always runs. All of this stuff has to do with cell inequality, but we know it runs based off the name. And we know that this else is always running, and so it can replace the parent. And we are now in a place where we're updating the cell inequality based off of the backstage passes name. And so I think we have now extracted successfully the logic for HBRE and the logic for backstage passes. And importantly, we've done this without knowing anything about backstage passes or HBRE. We can keep on keeping on here. We're going to start by extracting actually, you know, one thing we have been doing is pruning out the remaining conditions as we've lifted these conditionals out. So this might actually speed things up a bit. And I wouldn't mind doing that. So we know that this always runs, and that, so we don't need this or this else. So this conditional is always true, which means we can replace it there. We know that this conditional is never true, and so we can We know that this always runs. Or we don't know that it always runs. But we do know that the item name is never not self. Right, okay, so my test saved me there. I did something wrong. Okay, you can't. Okay, what we can do is ignore empty else's. So that's equivalent. We only ever run the consequent side of that conditional. So we have an empty else here. That same logic applies. We should get green again. And I took too many steps, but let's commit that. Right. Actually, so I used my brain a little bit too much there. I don't necessarily want to do that. Anyway, let's extract this method. I'm committing the shortcut to memory now. We're gonna do this whole thing all over again. And what we're gonna do is cover that last name conditional. I haven't talked at all why we chose name, but it has something to do with the requirements of the Gilded rows. So you're supposed to add a new item with a new name, and so that's kind of the discriminant in the problem, and so that's why it makes sense to extract that as the kind of value we switch the logic on. So we're going to duplicate the condition, and then we're going to inline. I think I just quit IntelliJ. Killer. So let's switch to the test, get the thing running with coverage again. Hopefully it'll remember my layout. Oh, it does, good. Inline, that is not the shortcut for inline. Okay, so it's actually Command N, Command Option N. Why would you want to keep a method afterwards? That's so weird. doesn't work, or that doesn't get called. This doesn't get called, which means that's empty, which means, alright, that's empty, that's empty, that's empty. Okay, so sulfurous, we don't actually do anything. So this, we've now done every item. And so, or we've done every item name. And so we can start using our brain a little bit with regards to this refactoring. We've already covered the sulfurous thing, so this is like a, this is, you know, always going to be true. The item is always not going to be named sulfurous, so we can put that there. The item name, again, is always not going to be sulfurous, so we can put that there. Item name. So we can put that there. And now we're in shape where we can see like how each item behaves. We can actually do something else here. We could say, okay, actually, let's commit, delete, always true ifs. These are my favorite commit messages ever. I'm using this notation that I think Arlo Belshi came up with. I'm actually not even using it very well. I probably shouldn't use it at all. All right, now we've covered all of our cases here. It's probably time to start thinking about what we do. It's time to start thinking, oh. Okay, so that's actually, our time's up. But what we should be thinking about, hopefully we get to this stage in the next practice session, but what we should start thinking about is what Sandy Metz and Katrina Owen call the flocking rules. And basically, it's you take two bits of code that look different, or look similar but different. I'm probably going to mistake this. The two pieces of code that look similar but different, make them look as close to the same as possible. Extract the differences or the similarities. I can't remember, and you'll start to tease apart duplication that way. They explain it in this book they have called 99 Bottles of Ruby or something like that, 99 Bottles of OOP. And so I'm actually going to review the flocking rules so that when we get to this part next time, I'm going to be able to start to extract some of the duplication out of this. So the original refactoring, this kind of like lifting the conditional out, extracting the method, duplicating the method or each branch, duplicating the method call into each branch, and then inlining the method and deleting the red. That refactoring is something that I've learned from watching a presentation that Lou and Falco gave. presentation, or the other technique that I want to use is called the flocking rules. And I think sort of as we get deeper and deeper into these practices, I'm going to be able to pull up more and more pull up more and more techniques that I've pulled or that I've read about, but not necessarily put into practice. So that's the hope anyway. Thank you for watching. The code will be in the code will be linked in the description in the YouTube comment, and it's all up on GitHub. So thanks very much.